One of the ways to solve the quadratic equation is to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. So in this case we have a as 5, b as negative 43, and c as 25. Now, before we go ahead and plug in the values to the formula and solve for x, we can take a hint here from what's under the radical. So this b squared minus 4ac value, not the square root, but just b squared minus 4ac, is known as the determinant. Now, if the determinant is greater than 0, then we're going to have two distinct real roots. So let's pick a simpler example. Let's make the a value 1, the b value something like 3, and the c value we will make also 1. So now we have the quadratic equation x squared plus 3x plus 1. If we use these coefficients to determine or to solve the determinant comes out to be 5. We have 3 squared minus 4 times 1 times 1 equals 5. 5 greater than 0, the determinant greater than 0 tells us we're going to have two distinct real roots, and we do. When we plug in the values to the entire formula and simplify, we're going to get these two roots, or these two solutions. So if x is negative 3 halves minus the square root of 5 over 2, or negative 3 halves plus the square root of 5 over 2, those values of x will satisfy this equation. Now if we drop the b value from 3 to 2, we're going to see something different. Now the determinant equals 0. We have a b value of 2, so 2 squared minus 4 times 1 comes out to 0. So when the determinant equals 0, we're going to have two equal roots, meaning when we plug all of these values into this whole formula and simplify, we're going to get the same solution twice. So negative 2 plus 0 over 2, negative 2 minus 0 over 2 is just negative 2 over 2. Both of them are negative 1. So in this case, we're going to get x equals negative 1 and x equals negative 1. So the only solution for x here is negative 1. That's the only value you can plug in for x to satisfy this equation. Now if we make all the coefficients 1, we're going to see something a little stranger. So when we use the determinant here to figure out what kind of roots we're going to find, we get a negative number. 1 squared minus 4 times 1 is negative 3. Now because negative 3 is the determinant and the determinant is now less than 0, we're going to get no real roots to the equation. So if you'll notice down here, we start getting imaginary numbers because we're going to get a negative number under the radical sign, which we can't do in the real number system. We're going to have to start using imaginary numbers, and there are no real roots, so no numbers in the real number system that will satisfy this equation. No numbers you can plug in for x that will satisfy this equation. So in summary, when the determinant is greater than 0, when this value under the square root sign is greater than 0, you're going to get two different solutions. When it equals 0, you're going to get one solution twice. So there's one real solution, two equal roots, but one number that you can plug in for x to satisfy this equation. And when it's less than 0, there's going to be no real roots, only imaginary roots. And to actually solve for x, it's as simple as just using this formula. You put the coefficients into this formula. You put b where b goes, a where a goes, and c where c goes. Simplify, solve, and there's your value of x. And this can be used to determine the solutions for the value of x that satisfy any quadratic equation at all, and you can also have coefficients of 0. So if it's just x squared plus 1, there's no x term, then b then is 0, and it goes the exact same way. So in this case, you're going to have a negative determinant, you're going to have no real roots, just imaginary roots. You can still plug in all of your values to the quadratic formula. Just remember to make b 0, and you get x equals negative I and I on the imaginary number line.